Assalamualaikum and hi to my beloved panelists. My name is Muhammad Nazreen bin Abdul Rahim and I am a member of 3BMMA Section 1 Stroke 2. Today, I would like to share with you my final year project that is called Development of an Emergency Brake for Underbone Motorcycle under 150cc engine capacity. For my supervisor, TS Dr. Muhammad Zakaria bin Muhammad Nasir is supporting and assisting me with this project throughout this semester. Okay, this is my presentation outline today, which I will explain in detail later. There is an introduction, followed by a brief literature review. Then there is a methodology. Finally, the preliminary result that demonstrate the progress made with PSM2. First of all, the introduction shows the problem statement, research objective, and scope of research. First, we go to problem statement. The problem statement for this project is what is the improvement that can be used to the conventional brake, and then how to design the most reliable and safest brake system in underbone motorcycles. And lastly, is this brake system can be modified in underbone motorcycle. Okay, and we go to the research objective. Firstly, the research objective is to conduct research into the development of a more effective brake system for underbone motorcycles using a combined front and rear brake system. Then, to develop a combined brake system for a underbone motorcycles. Lastly, to measure and evaluate the stopping distance during braking in any road condition, such as wet or dry condition or on asphalt or the cement uh, and others. Okay, for the next slide, it show that my scope of research. Firstly, I conduct a survey to ascertain the most frequently used brakes by motorcycle riders and develop a design concept for motorcycle brakes under 150cc. Next, I conduct an analysis of conventional braking system using CATIA software, and then I develop a new brake system at the actual underbone motorcycle by fabricate and modifying it. Lastly, I will testing and research of new combined brake system performance that can be compared to the conventional brake. Okay, next I want to go through to the literature review. In my literature review, I will explain the statistic accident in Malaysia. Firstly, the figure in the slide show that general road accident statistic in Malaysia from 1997 to 2017. As we can see, road fatalities and injuries are becoming growing concern in Malaysia, with over 6,000 persons killed and over 25,000 wounded annually over the last 5 years. Road deaths have climbed at a constant pace at 4 to 5% per year for the last 7 years. Can be reached until 6,745 in 2009. That caused an average of death per 100,000 people. Okay, for this statistic, for the figure at left show the statistic of death by road user category in 10 years, and then figure at the right side shows the number of registered vehicle in 2017 and several months in 2019. As we can see, motorcycle accident by average is 4,100 in 10 years, and the total death by accident motorcycle was reached until 43,031 deaths in 10 years. Therefore, motorcycle users has most number of accident compared to the other category. Meanwhile, number of the car and motorcycle registered in Malaysia has almost the same number. This means that the motorcyclist has more exposed to the death when accident compared to the cars. Okay, this is my research methodology. that I illustrate in the flowchart. The project is started by collecting the information and idea, but I read a bunch of journal and the article that related to this project. Next, I written the literature review for a gain and understanding of existing research and debates relevant to a particular topic or area of study. Then I do some concept design to be compared. Next, I conduct the survey by using Google Form to collect the data from motorcyclists. By using design selection matrix and house of quality, the design selection can be made by choose the most suitable characteristic that I need for this brake system. Next, I will do the fabrication and modifying at actual motorcycle, underbone motorcycle, and then I will test the brake distance test. If the result of the test is failed, the design selection and new fabrication must be done again. After all of the test has been success, final report can be made. Okay, this is my for the survey. The survey is can be gathered using a Google form. According to this survey, 63 respondents answer most of the question on the form. Okay, for this, what I can conclude for both pie chart is every respondent that own underbone motorcycle has involved in accident, and some of them because of brake failure. Uh, what I say because 69 point 61.9% owning a underbone motorcycle, but and they also involved in accident motorcycle. Okay, we just go through the pie chart. This is leading causes of motorcycle accident. What I can conclude here is the main factor of accident can happen because of careless driver and rider. Brake failure also one of the leading causes that can might happen. Because of the total number careless driver or rider is reaching 47 and the brake failure is reaching 25. Okay, for this survey, what I can conclude here is most respondents prefer to use front brake as their emergency brakes. Respondents also choose this brake for their motorcycle brakes for getting better braking performance. Okay, next is the pie chart that show that the brake combination preferred that respondent answer. As we can see, most respondents choose front and rear use uh, this brake. So the this survey can be related to previous questionnaire that I asked disc brake or drum brake is better. Next is a pie chart is respondent answer for simple and low cost combined brake system. So as we can see, there are 82.5% of respondents assume that installing a mechanical combination braking system in a underbone motorcycle is easy, simple, and low cost. Meanwhile, electronic combination brake system receive only 17.5% of respondent votes. Okay, this last pie chart show the respondent answer for the most important in developing a brake combination. What we can see, 65.1% of respondents prefer maintenance. This implies that most respondents put a priority on maintenance, as many people nowadays like to properly maintain their vehicles. Additionally, the pie chart indicates that 23.8% of respondents believe that cost is a major factor in a developing combination braking system for an underbone motorbike. Okay, we go to the concept design development. Okay, this is my design A. Design A is a combination brake system with using front disc brake and rear drum brake. When the foot pedal is pushed hardly downward, this is how this design operating. When the foot pedal is pushed hardly downward, master pump will transfer the brake fluid to the T junction to equally transfer the brake fluid to rear and front brake. Commonly, drum brake use wired system to pull the cable for braking, but this system must use hydraulic system to pull the caliper outward using hydraulic puller. And then for the design B is combination brake system that almost the same like design A, but uh, the system operated is almost the same, but design B doesn't need to use the hydraulic puller because because design B use both disc brake that as we know this brake use hydraulic system for operating it. Okay, for design C is completely different to the others two design as shown in the uh, slide. And this is because design C operating by using electrical component such as proportioning control valve (PCV), electronic control unit (ECU), a modulator with speed sensor, a delay valve, uh, and many other things to operating this brake system. This combined brake system can be programmed through computer and allows the rider to select the type of braking required. The caliper is also slightly different due to the presence of two hoses leading to the single caliper. This is because ECU needs to decide for brake fluid flow in and out. Okay, this is my preliminary result. We go to my preliminary result that I show in the animation video. It's my uh, this is my project design idea that I will fabricate on actual underbone. Front and rear brake caliper can be combined by using T-junction brake hose. Then there will be brake valve limitation to get the best braking ratio. The junction can be located T-junction can be located near the rear master pump, and the bracket for T-junction or any other modification will be needed to finish this project. Okay, this slide shows the comparison between other combined brake system with my project. Motorcycle manufacturer has already created this kind of combined brake system, such as Kawasaki with their KL Kawasaki system. Then Suzuki also has produced this system that called combi brake system. The major difference that can be spotted is my combined brake system is targeting to install at underbone motorcycle. Meanwhile, Kawasaki is use this system on their touring bike that has uh, that can be reached until 1400cc engine capacity. And Suzuki is targeting at the scooter. In addition, budget for this combined brake system is very high for the other manufacturer. But for my combined brake system, the budget is very low to make sure motorcyclists able to install it. Next, other combined brake system is very hard to install in their motorcycle because of there are a bunch of electronic system that must be used to operate it. For my brake system, they are all mechanical. That's why my system is easy to install. Furthermore, superbike need more safety equipment because of the bike can reach until 299 km per hour. But for underbone, it's only around 100 to 150 km per hour only. That's why the combined brake system that Kawasaki has created is very sophisticated and high cost. Okay, that's all from me. Thank you.